Okay, 7.3. This time, what we're going to do is that now we're kind of getting, they jump away from the multiplication and division, and now we're getting more to adding and subtracting, which has a different set of rules. The good thing is with 7.3, it's a transition that with 7.3 they kind of back way up and have you kind of get to the point where it's really just kind of a review section is really what 7.3 is. So before we start adding and subtracting here, hang on a second. This one we're actually really finding more the least common denominator. Okay, and with these, they don't even ask you to worry about rewriting them. They're saying, all right, let's just find out what the least common denominator is going to be. And for this one, you can look at it a couple of different ways. You've got a 9 and a 6. And, again, a couple of different ways you can think about it. If it's just numbers, just start with a number and you just start counting up. 6, 12, 8, just do the multiples. 24, 30, that kind of thing. Do the same thing with the other denominator. And then as soon as you run into one that they have in common, that's the number you're looking for. Okay, 3/10 and 7/6. Same thing. Just start counting by your 6s again. Now again, with 10s, it's pretty easy. Just list off the 10s till you find one that they would have in common. Eventually 30 would be the first number that you would get here. So some of the numbers you're going to look at it and you're going to go, okay, it's really easy. Some of them you may have to count out just a little bit to kind of figure out what's going on. But number-wise, that's all that you have to do. Okay, objective 2. They changed gears just a little bit on this one. But it's still basically the same thing, just a different wording. They tell you to find the least common multiple. And the only difference between the least common denominator and least common multiple is it's the exact same thing, but there's no fractions on it. That it's still, when we're doing this one back here, when you're finding the least common denominator, you could take that denominator part out and change the least common multiple of the denominator. The only thing that's different on this one is it's just the least common multiple of whatever numbers that they happen to give to you. So we'll go with 14 m squared u to the 8th. And then 21 m to the 6th u to the 4th. And then x to the 7th. Okay. Now, if you go back, and this is the opposite of factoring, because factoring was the greatest common factor. This one's the least common multiple. So the number-wise in the beginning, you start off with basically the same thing. You start with 14 and 21. Just start counting the multiples until you find a number that they have in common. Okay, so number-wise, that part's going to be the same thing. The variables, it's the opposite of what we did for greatest common factor, because greatest common factor was, we found the factors of the numbers, and then we took the smallest power that any of the variables have. For least common multiples, it's the opposite. You pick the biggest power. So the number-wise, same thing. It's, as you're going through these, Variables, it's pretty straightforward. You get m squared and m to the 6th. You're going to use m to the 6th. You've got u to the 8th and u to the 4th. You're going to take u to the 8th. No x's here, x to the 7th, so you have to take the x to the 7th. Okay, so again, because they're going different opposites. Factors, the numbers we're getting smaller. Multiples, you're getting bigger. So with factors, you took the smallest thing they had in common. Multiples, you pick the biggest number that they have. Okay, so again, you're going two opposite directions, so there's not much with those. Okay, so to kind of throw that one in the middle, objective 3, they're back to the same thing with least common denominator. So that even though this one is least common multiple, it's still pretty much least common denominator. They just don't give it to you in the denominator form. Let's try it again. Okay, still finding the LCD back to this one. Do 9x over x minus 7. And we're going to do 5x over x minus 6. Okay, and the biggest difference between this least common denominator we're finding with objective 3 than objective 1, objective 1 is just numbers. This one we got linear expressions, which again is your x minus 7 and your x minus 6. Okay, so basically you're going to use x to the first power. And this one is almost set up the same way, that anytime you have a different power or a different expression here, that x minus 7 is a little bit different than x minus 6, it's basically like this is a variable kind of like m is, and this is a variable kind of like u would be. So if there's one number different, they're totally separate, unique expressions. So if they ask you for the least common denominator with two different expressions, it's just going to be those two things multiplied together. It's x minus 7 and it's x minus 6. So each different expression that's in the denominator has to be a part of the LCD. You know, if you had x minus 7 and an x plus 7, those are two different things. Those two things would have to be in the denominator. You know, if they gave you four denominators and each one of the things was different, then you'd have a least common denominator that would be all four parts and pieces of this thing. All right, let's give you one more of those just to make sure we kind of got it here. Oh, wait, hold on, wrong problem. I'll change that one real quick. Hold on one second. Got too far ahead of myself here. Looked at the wrong spot. That one's okay. Wrote the wrong one here for this one. Let's make this 5 over x plus 2. Okay, and same thing with the last one. X plus 2 is different than 2x, so those are two totally unique expressions there. So your least common denominator would be 2x times x plus 2. And again, if especially with these, when you get the pluses and minuses, even though it's not there, go ahead and think about that x plus 2 or whatever it is that's got the plus as having parentheses wrapped around it so that it's always stuck together for that thing. Okay, objective 4, still finding the least common denominator. The only thing they do different with objective 4 is that they're going to tell you, okay, this one is going to have some common factors. And you may not see it exactly in the beginning of it, but once we do one or two of these, you'll go, okay, got what's going on here. Okay, so they'll set it up the same way. We'll do 2x over x plus 1 for one of the fractions, and then the other fraction is going to be negative 3 over 5x plus 5. Okay. Now, and when you're finding the least common denominators, if you can factor the denominators, you factor them as much as you can. And it shows up here, but we'll also use it later on with all the things we do. Okay, so as your denominators start to get a little bit more complex, basically you're trying to look and see if you can factor out your denominators. Factor them out as much as you possibly can. So for this one, again, not the first one, nothing you can do there. It's 2x and it's x plus 1. But the second one, you've got the 5x plus 5. You can factor out a 5, make it x plus 1. Okay, so then to get your LCD, you've got an x plus 1 that's here. It's in both of them. And the 5 is extra, so you also need this 5 that's here. And let me write that a little bit better. So that sometimes people, if you don't factor that one off, they'll look at this and they'll go, all right, well, here's x plus 1, that's one denominator. Here's 5x plus 5, that's another denominator. You know, so I got to multiply those two things together. But no, if you take those things and factor it, this is actually an x plus 1 that's multiplied by 5. And since you've basically got x plus 1 to the first here and x plus 1 to the first here, you only have to have the x plus 1, and then you've just got the extra number that's multiplied out with it there. Okay, so just one more of those. So we'll go 9 over 2x and then 1 over 4x plus, so we'll get 16. Okay. Okay, 2x, nothing you can do with that one, but you have 4x plus 16 here. So if you take this denominator and factor it out, that leaves you with 4x plus 4. Okay, so this denominator, we didn't do anything with it. So now here's where sometimes you have to kind of, and this one will sneak up on you a little bit, because we got an x here, we've got an x plus 4. So those are two different things. And you almost have to just kind of, that when you take out the variable part, we take out this x plus 4, you take out the x. If it's 2 and 4, what number? What's the first number they have in common as you get bigger? 4, right? Sometimes that'll sneak up on people that they'll kind of forget about the numbers because they're so keyed on the variables. So once you take the variables out and, okay, we had an x here, we had an x plus 4 here. If it's 2 and 4, well, now it's back to just, listing off the multiples. 2, 4, 6, 8. First number they got in common is a 4. So that would be that part. So sometimes it's a temptation that you focus in on the variables because you're worried about the expressions, and then the numbers are just kind of sneak in and get you a little bit. Okay, so just don't let those sneak in on you. Okay. And objective 5, same setup, same type thing. The only difference is now with objective 5, your denominators, now you have quadratic denominators. Okay, but it's still the same thing. You factor out your denominators as much as you possibly can, and then you see what you have left over from there. Okay, so it's still the same thing. You still got to factor out your denominators first before you do anything else. Okay, so for the first one, you're looking for the factors of negative 48, where the sum is going to equal negative 8. It's not 1 in 48. It's not going to be 2 in 24. It's not going to be 3 in 16. 4 and 12, 6 and 8. And again, since the b term is negative, b term is negative, that means the bigger number is negative. If you divide a negative and negative, it makes that one a positive. So the only way to get 8 out of these numbers would have to be the 4 and the 12. Okay, second one, a little bit easier to factor in because it's 2 perfect square numbers. So that one's going to be an x plus 5 and an x minus 5. Okay, and you have to think about it that anytime the denominators are the least little bit different, they're like individual letters. This is like an A, a B, a C, and a D. Well, if they're all different letters, then you've got to have them all together. So your least common denominator is just going to be all 4 of those things in no order. As long as you got the 4 things there with correct signs, that's going to be your least common denominator. Let's do one more of those. So for the second one, we'll go with x squared. So x squared minus 6x plus 8, and then x squared minus 8x plus 12. Okay, factor this one off. The factors of 8 that's going to get you to 6, well, it's not going to be 8 and 1. It's going to have to be 4 and 2. B term is negative, so the bigger number is negative. If you divide a positive 8 by negative 4, also makes that one a negative 2. Okay, for 12, it's not 1 times 12, 2 times 6, 3 times 4. The only way you can get 8 is it's going to have to be 2 and 6. And same basic setup on that one, because the b term is negative, the bigger number has to be negative, and if you divide a positive by a negative, it does make that one a negative. Okay, now, good thing on this one is you do have an x minus 2 that's here and here, so you only need to have the x minus 2 one time, but you do need an x minus 4, and you do need an x minus 6. Okay, and again, the biggest thing they're trying to hammer home in 7.3 is that if you're getting least common denominator, every expression is a very unique expression, and you have to include everything that's there. If this had been an x plus 2 and that was an x minus 2, we'd have to go back and put another x plus 2 in there, because again, one little sign different means that those are totally different expressions. Okay, and then the last two things in 7.3. They're actually giving you some fractions on these. And to me, they're a little bit shorter. These you know, as long as 5 and 6 started getting with all the factoring you had to do, 6 and 7 actually kind of get short. The objective 6 and 7, they're basically just going to tell you the right equivalent expressions. Which basically just means, okay, we've changed the denominator. Whatever you did to change the denominator, you've got to do the same thing to change the numerator. So all you got to do is say, all right, I had 4, I got 12, multiplied by 3. Same thing here, you just got to multiply by 3. So that's not a small box. Okay, I'm going to put the box answer down here. So 3 times 3 would be 9. I had u to the 8th. Now I've got u to the 9th. I added an extra u. So I'm multiplied by basically u to the 1st. Same thing up here, you're going to have to multiply by u to the 1st to make that a non-u. There you go. Now, and you can almost kind of reverse it around and say, all right, well, here's this expression they started with. They took this expression and simplified it to here. What was the missing numerator? One of those kind of things. Ever how you want to look at it, that's, you're just kind of filling in the gaps to get what you need there. Do another one of these real quick. So 9 over 4v squared equals, make my box bigger here. V to the 5th. Okay, number-wise, it didn't change. Went from 4 to 4. The only thing we did here was we added in an extra 3 v's. So we put in a v to the 3rd. Same thing here. You just have to put in a v to the 3rd. Well, we already have 9, so it's 9v to the 3rd. Okay, objective 7, same thing. They just change the equivalent part of it. It's still basically the same thing here. The only thing they do for these is they bump up what the denominator looks like. Okay, so for this one, you've got 3x over x minus 7. Now we've got something over x minus 7 and x minus 4. Okay, all we did here in this case was we multiplied in an extra x minus 4. Same thing here, just put in an x minus 4. And you don't have to do distributive property, you just put the number in there and that's all you have to do. So that's going to be 3x, x minus 4. That's it. So whatever they did extra on the bottom over here, you did the same thing on the top. And they're getting us ready for the next section that's coming up when you have to start adding and subtracting numbers, because when we start adding and subtracting numbers, you have to have a common denominator. And that's kind of where they're tying into this thing. Okay, same thing here. We put in an extra u plus 2. So over here, same thing, you've got to put in, or basically multiply by u plus 2. So that's 2u times u plus 2.